Today, we're going to look at your last lesson in Algebra 2 over scatter plots and regression. So now we're talking about two variable data is collected as paired variables, such as a series of measurements of air temperature at different times of the day. So we're talking about two things being measured. Here it mentions air temperature versus times of the day. Maybe this is age and height. Maybe it's time spent on homework and a quiz grade or grade in the class. Two things that we're measuring and looking at their patterns. So that is going to create a scatter plot for us. A scatter plot is used to visualize two variable data using a graph of points with one variable along each axis. And then looking at that pattern, it creates what we call correlation. Correlation is a measure of strength and the relationship between two variables. So I've got three examples there to the right of correlation. We have first positive correlation. If you see that your data is going up from left to right, that's positive correlation, just like positive slope. Negative correlation, if you see that the data is going down from left to right, that is going to be negative correlation. And then no correlation, see how this one is just completely scattered? I call it a starry sky. If it looks like a starry sky, there's no pattern, no correlation. So hopefully that's a little bit of a review from 8th grade math. You talk about scatter plots. You also talk about scatter plots in Algebra 1. So we're going to take it a step further, of course, for Algebra 2. Scrolling down, describe the correlation. Remember, that's like the direction and the strength in each scatter plot below. On the left, we have a scatter plot shows blank correlation. I do see that the trend is going down from left to right. So it is negative, it is linear, but we also have this guy out here as an outlier. So the scatter plot shows a negative, linear, and this is a drop-down box on Delta Math with one outlier. Correlation between, because as plotted values of x increase, the value of y generally decreases. In the middle one, the scatter plot shows blank correlation. Look at that one. So you can see that has a very nonlinear correlation. That's exactly what goes here. Nonlinear correlation, because as the plotted values of x increase, the value of y generally follows a nonlinear pattern. Again, drop-down box on Delta Math. Follows a nonlinear pattern. And the last one here, this scatter plot shows blank correlation. Nope, that's not really good. And no. So this is going to be a no correlation because the plotted values of, as the plotted values of x increase, the value of y generally shows no pattern. So those are three examples there from Delta Math. Again, those are all going to be drop-down choices for you, practicing identifying which type of correlation each scatter plot has. All right, now for moving into the Algebra 2 step. So we are going to model this data, these correlations that we see in our scatter plots with regression. A calculator, we're going to be using your Inspire calculator quite heavily for this, can produce what's called a regression to model the relationship between the two variables. A regression is going to be a function or what you may call an equation to help represent that data. And then we can use it to make predictions. So we're going to plug in our data into the calculator, ask it to calculate what's called a regression to help us track our data. So two types of regression we're going to be working with: a linear regression. This one you're actually kind of familiar with because it is hit on in 8th grade in Algebra 1. We just call it a line of best fit. So a linear regression is going to create a line of best fit between two variables by fitting a linear equation to the observed data. So in 8th grade math and Algebra 1, you're kind of just guessing at it. We are going level Algebra 2. The calculator is going to give us an actual precise equation that fits the data. It's not a guess and a maybe and kind of somewhere in here. it's exact. So that's why we are relying heavily on the calculator. And then the last part here is an exponential. An exponential regression is going to generate an exponential curve. Recall, exponential functions exponentially grow or decay. They kind of have that rocket ship or that decay curve there. It's going to generate an exponential curve that models the data set. So let me doodle up here that linear pattern, right? And like I said, regression, that's all it means. It's going to fit a function, and we're looking at two function families, linear and exponential. We've studied both of them kind of interchangeably throughout the year to fit our data. And then we're going to use it to make predictions. So I've got calculator steps on page 2 and examples of what we're doing here. So grab your calculator. We are going to enter the data into lists and spreadsheets. And then we are going to use that page to generate this regression. So I've got my calculator pulled up. Guys, I know it's small right now. I promise I'm going to move it and I'll make it bigger. But I wanted to make sure we could see everything on the page here. We got our calculator steps at the top. I'm going to start with number 1, kind of get us into the problem. We are going to need all those values from the table. And so then when I'm done with that, I can move my calculator around. So number 1 says the number of newly reported crime cases in a county in New York State is shown in the accompanying table, where X represents the number of years since 2007 and Y represents the number of new cases. Write the linear regression. That's our first step. Write a linear regression equation that represents the set of data, noting we're going to round all coefficients to the nearest 10th. So directions here change throughout the Delta Math problem, so make sure you read closely how we're rounding. So we're going to write a linear regression equation, rounding everything to the nearest 10th. And then part 2 is we're going to use that equation to predict or to find the projected number of cases for 2019 rounded to the nearest whole number. Okay? So looking at our calculator steps, we're going to enter our data into a list in spreadsheets. So not sure if we've used one this year. You can go from a new document. Let me just show you that. New document, and you can go to number 4, add list in spreadsheets. Or on the home screen, what it references first there is down here at the bottom, and you have the apps. The middle one is list in spreadsheets. So 2 different ways you can go to it. You can go to the middle app, open a list in spreadsheets, or you can go from a new document, and instead of selecting calculator or graphs, you're going to select make a list or spreadsheets. So we're going to enter each of our each X value into column A. So let's put in 0. And again, we'll make this bigger, I promise. 1, 2, 3. Column A. Arrowing over, let's enter all of our Y values into column B. 1,027, another 1,027, 1,094, and 1,096. Let's see what we have next. Name each column at the very top, next to your letters up here, not in the equals row. So we have A, B, C, D across the top. That's where we're going to name them. Below that is equals, an equals row, not there. And then we have our data. So in the letter boxes, my first column was years since 2007. So I'm going to call it years. And we are going to, in a minute, the calculator is going to ask us which column we want. So that's why we need to label them. We can also label them X and Y, but if you're doing multiple problems, you're going to have multiple X's and Y's. And I'll show that. I'll illustrate that in a little bit. Our next column is new cases. So I might just call it cases. You can do whatever works for you. You don't have to do exactly what I do. So we've entered our data. Data's good to go. On the right side, find the regression. So menu, let's get down here in the statistics into our data. I'm not sure if it works up there at the top. Let's hit menu. We are going to do number 4, statistics, stat calculations, and then you need to choose which type of regression based on your problem. So in our problem, and Delta Math is very, very kind, they always tell you what kind of regression you need. So we're writing a linear regression. So I'm going to select number 3, linear regression, mx plus b. Yes, like slope-intercept form, y equals mx plus b. So number 3, Here's where delta map, where your calculator is asking which column you want. So when you hit the center OK button, there it lists all the columns that you've named. X was years. Hit the tab key to go to the next box, and we will select cases for Y. And that's the only two things we need to enter. Everything else you can tab down to get to OK. And here we're going to have it to the side. Let me pull this over. I'll make it bigger for you. So beside our columns of data, there's column A, column B. It has written all this information over here to the side. Linear regression mx plus b. The equation looks like y equals mx plus b. My m value is 27.4. I can even, well, let's look at b. B is, 1019.9. And there's some more data here that we don't need. Actually, R is your correlation coefficient. So there's something. So we are going to write our linear regression equation, y equals mx plus b. We are going to plug in 27.4 for m, 1019.9 for b, and that's our equation. So let me get that written down for us. Y equals mx plus b. We said that m was 27.4. Got it written here on my paper. And b was 1019.9. Let's plug that in to make our equation. Y equals 27.4x plus 1019.9. It was write a linear regression equation rounding to the nearest tenth. I was given to the tenths on my calculator, so there was no rounding that had to be done here. Double check it. Sometimes there does need to be some rounding, okay? Part 2, I'm going to switch colors here. Part 2, we're going to use the equation to find the number of new cases for 2019. Hint, hint, wink, wink, pay attention, and round to the nearest whole number. Pay attention because we were given number of years since 2007, and we're finding 2019. So let's do 2019 minus 2007 is going to give us 12 years. We will plug in 12 for x. You see that? Plugging in 12 for x will tell us how many new cases y. So y equals, into my equation, 27.4 times 12 plus 1019.9. Plug it in your calculator, and we are going to get y equals about 1348.7. Rounding to the nearest whole number. 7 says round up, so we're going to have 1349 cases. 1,349 cases. Okay, so you got two steps going on here. Lots of them, or each of them have specific rounding rules. So there's kind of 4 things you need to check. Writing your equation. What kind of equation? Linear, or in a minute we'll see an exponential. Rounding that correctly. What information were you given? X or Y, plugging that in and making sure we round correctly. Okay, let's look at number 2. Number 2, the annual profits for a company are given in the following table, where X represents the number of years since 2000, and Y represents the profit in thousands of dollars. Write the linear regression equation that represents this data set, so linear still, and rounding to the nearest hundredth. Hundredth is 2 decimal places, right? Right. All right, so let's grab the calculator, let's plug in the data, and we'll get that linear regression equation done, and then we'll look at part 2. From here, I can do a couple of things. I can go from the home screen and start all fresh over, or you can do Control Document to give you a new tab at the top. Again, we're using lists and spreadsheets here. Notice now I have a new tab at the top, 1.2. I'm going to plug in 0, 1, 2, 3. Column B, 53, 141, 110, and 187. Let's name them. How about this time? I'll name them X and Y, but you're going to see that I still have my old labels in there. So if you did X and Y for example number 1, you need to name it something different or indicate somehow this is number 2. Maybe you want to do X2 and Y2 for problem number 2. You can name it whatever. Now let's come down here out of our data, and we do what? Menu, statistics, stat calculations, and we're again finding a linear regression. That's number 3. Linear regression, y equals mx plus b. Look at all of that. There's a lot of different data in here from where we solved last time. I just named them X this time for years since 2000 for this problem number 2. Using tab, let's get my Y for profit. And okay. I've got column A has all my years since 2000, X values. Column B is my profit. Here's where the calculator's generated all my data for my linear regression, where M is going to be 37.1 and B is going to be 67.1. Let's get that written down. Y equals mx plus b. We're plugging in for M, 37.1. And B is going to be 67.1. So we have Y equals 37.1x plus 67.1. Don't forget your X. Don't forget to start it with Y equals. You're writing the entire equation. Now, part 2, let's switch colors. How about red? In using this equation, estimate the calendar year in which the profits would reach $404,000. We were given $404,000, which is profits. That's information we've been given. We are finding the year, which we'll need to calculate after 2000. Yes? So let's take our equation. We're plugging in profit, which was Y. 404 equals 37.1x plus 67.1. Solving that, like subtracting 67.1 from both sides, we get 336.9 equals still the 37.1x, divide, gives us 9.081, just to have it already written down on my paper here. We're finding the calendar year. So this is about 9 years, yes? But it's not in year 9 AD. It's 9 years after 2000. So 2000 plus 9 years, guess what, is 2009. That is our answer. That would be in our final answer box. So 2 questions going on here, writing our linear regression, rounding properly, and then following it up with making an estimate based on that equation and making sure we're rounding correctly or answering the question correctly. Last example you have for you on your notes here. Let's look at number 3. The accompanying table shows the value of a car over time that was purchased for $16,400, where X is years and Y is the value in dollars. Write an exponential regression equation. That's a first for us. Rounding all coefficients to the nearest hundredth, 2 decimal places. And then we'll use the equation to determine the value of the car to the nearest cent after 8 years. So grab our calculator. Let's just go for it. Let's see if we can add all 3 on our calculator at the same time. Let's do 0, 1, 2, 3, 4. Column B, 16,400. Then we have 13,630, 12,399, 10,351, 9,449. Okay, let's label them. I'm going to abbreviate years, YRS, because I already did years before, right? YRS. And then let's do value or dollars. Already started typing value. So years abbreviated and value. Maybe I should have done X3 and Y3. That just sounds so smart now. So let's come down here into the data. menu, statistics, stat calculations. We're doing what this time? Exponential regression. It's A. Exponential regression. It said it there in the problem. We have abbreviated years, YRS for me. I've got, what did I do, value? So it's going to be down here at the very end. So they're alphabetical there. And okay. So column A was all my years. B column was all the value of the car. And then the calculator produced all this data over here for me. My exponential regression, remember an exponential function is y equals a times b raised to the x. Exponential, the x is your exponent. For those values, a is going to be 1680.6949. You see how I can see down here in the bottom any extra values? And then b, a 0.871278596, right? So if I need to check if there's more decimals that I'm not seeing in the tiny boxes, you can look down here in your equals line. Okay, so let's get that written down. We are rounding to the nearest hundredth. So exponential y equals a times b raised to the x. A was 1680.694. You see how I'm looking down here? 694. We're rounded to the hundredths, which will be the 6.9. The 4 tells me to let it rest. So 0.69 there. 1608.69 and B 0.87. The 1 tells me how to round, says let it rest, so 0.87. So plugging that in, y equals 1680.69 times 87 hundredths raised to the x. There's your exponential regression equation. Part B, use the equation to determine the value of the car to the nearest cent. That's 2 decimal places. Money, pennies, cent, hundredths place, after 8 years. Well, we've been given the number of years. 0 years, 1, 2, 3, 4, 5, 6, 7, 8. We're plugging in 8 for x, and that'll tell us the value. Simple enough. So y equals 1680.69 times 87 hundredths raised to the 8th. And grab your calculator. Let's do control page. Let's just do a quick calculator page. 1680.69, right? Times 87 hundredths raised to the 8. 5,277. And how are we rounding this answer? To the nearest cent, so hundredths again. 87 cents. 5,277 and 87 cents would be the value of the car, based on the data that we have right now, would be the value of the car after 8 years. Okay, so you've got a handful of examples on homework where you're plugging it in your calculator, you're following these steps. Read your questions carefully. Are you looking for a linear regression or exponential regression? And then following it up with answering a question. We've seen these modeled on benchmarks before, and therefore I assume on your EOC. It's the same kind of concept. They give you like a table of ordered pairs, a table of data, and it's just not possible to estimate, like keep a pattern going or find the value in between, where it really is just best to throw it in your calculator and get that equation. And the question could either be asking to predict or just asking which equation would match the best. And so this is a really great skill for those 1 or 2 questions that might come up. So practice those. So we reviewed scatter plots, again, from 8th grade math, Algebra 1. Here it is, Algebra 2. We're taking it a step further beyond correlation into creating these regression equations that we use the calculator to do. So let me know if you have any questions, guys. I hope you have a fabulous day, and I'll see you soon.